Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the JEE Main examination held in January 2025 session. And this is the second part out of the three parts of the binomial theorem. Right, this question has appeared in the JEE Main exam held on 29th January 2025 in the second shift. The given question is the remainder when 7 to the power of 103 is divided by 23 is equal to. We are given four options. Let's now discuss the solution of the problem in detail. We want to work out this problem using binomial theorem. Some students and the teachers discuss the same problem using congruences in number theory. But my intention is to discuss this problem under binomial theorem. 7 to the power of 103 is written as 7 into 7 to the power of 102 is equal to 7 into 7 to the power of 51 multiplied by 7 to the power of 51. Now 7 to the power of 51 is 7 cube to the power of 17. 7 cube is 343 to the power of 17. The idea is to write this 343 as some multiple of 23 and adjust the term. Now it is written as 345 minus 2, where 345 is a multiple of 23. 345 is 23 into 15. So a multiple of 23 minus 2 to the power of 17. Now apply binomial theorem. Now that will be equal to 17c0 into 345 to the power of 17 plus 17c1 into 345 to the power of 16 into multiplied by minus 2. And 17c2, this is not n1c2, 17c2 into 345 to the power of 15 into minus 2 to the power minus 2 square plus so on and so forth plus 17c16 345 into minus 2 to the power of 16 plus 17c17 into minus 2 to the power of 17. Now look here, all the terms barring the last term except the last term, each one is a multiple of 345. All these is a multiple of 345. Therefore, we write M345 which denotes some multiple of 345, M345 plus the last term is minus 2 to the power of 17. Agreed. And now multiple of 345 is same as is some multiple of 23. Right. Why? Because 345 is 23 times 15. So multiple of 345 is some multiple of 23 plus minus 2 to the power of 17. Now 7 to the power of 103, recall, is equal to 7 into 7 to the power of 15 multiplied by 7 to the power of 15 is equal to 7 into 7 to the power of 15 whole square, that is multiple of 23 plus minus 2 to the power of 17 whole square. Now when you square it, you get 7 into multiple of 23 plus minus 2 to the power of 17 square, that is 2 to the power of 34. So you will get, I know you have to expand this, m23 into m23 is multiple of 23. 2 into m23 into minus 217 is some m multiple of 23. So that is clubbed here. So plus 2 to the power of 34. Agreed. Now this is 7 times m23 is multiple of 23 plus 7 into 2 to the power of 34. So you are clubbing everything into the multiple of 20, some multiple of 23. Right. Now take this 2 to the power of 34 and write in a similar manner. So 7 into 2 to the power of 34 is 7 into 2 square into 2 to the power of 32. What is our what is our concept? Our concept is you have to write down, to a convenient number which is a multiple of 23 plus something, then apply binomial or whatever you like. So this is 7 into 2 square, 4, 7 4s are 28 into 2 to the power of 8 to the power of 4. Right. This 28 is written as 23 plus 5 into 2 to the power of 8 is 256 to the power of 4. Right. Now, what you do is 23 into 256 to the power of 4 is some multiple of 23 plus 5 times 256 is written as 253 plus 3 whole to the power of 4. And that is equal to m20 multiple of 23 plus 5 times when you expand this by means of binomial like here, you will get some multiple of 23 plus last term 3 to the power of 4 like here. So the same thing is written here. So then now 5 times of multiple of 23 plus multiple of 23 is some multiple of 23 plus 5 times of 3 to the power of 4 is 5 times of 81. So 5 times of 81 is 5 times of 69 plus 12. So 5 times of 69 is some multiple of 23 and with this multiple of 23 is some multiple of 23 plus 5 times 12. So 5 times of 12 is 46 plus 14. 46 is 2 times of 23. So m23 plus 2 times of 23 is some multiple of 23 plus 14. So come back here, substitute here. So m23 multiple of 23 plus multiple of 23, some multiple of 23 is equal to 14, some multiple of 23 plus 14. Now divide by 23. If you divide by 23, you will get the remainder is 14. So remainder when 7 to the power of 103 is divided by 23 is 14. So where is the answer? The answer appears against option 2. Therefore, the answer to this question is option 2. That is the detailed discussion of the solution of this problem using the binomial theorem. Right. And using the congruences and the number theory, and you may get the answer comparatively quickly than this. Right, that will take less time, but our intention is to work out this problem under binomial theorem. Right. Now we move to the next question. This question has appeared in the JEE Main exam held on 29 January 2025 in the first shift. The given question is the least value of n for which the number of integral terms in the binomial expansion of cubed root of 7 plus 12th root of 11 whole to the power of n is 183. We are given 4 options. Let's now discuss the solution of the problem in detail. We have the cubed root of 7 plus 12th root of 11 whole to the power of n write down using the binomial. That is sigma r is equal to 0 to n, NCR into cube root of 7 to the power of n minus r multiplied by 12th root of 11 to the power of r, where r varies from 0 to n. 0 less than or equal to r less than or equal to n. Right. The general term is NCR into cube root of 7 to the power of n minus r multiplied by 12th root of 11 to the power of r. Right. This is equal to NCR 7 to the power of n minus r by 3. Cube root of 7 is 7 to the power of 1 by 3. So, into 11 to the power of r by 12. So, this is NCR 7 to the power of n by 3 minus r by 3 into 11 to the power of r by 12. Now, to obtain integral terms, what do you mean by integral terms? So, the terms which are integers. And integral terms, 12 must divide r and 3 must divide r. These two put together is 12 divides r and 3 divides n. Then you will get integral terms, otherwise you will get irrational terms. Right. 12 divides r means what? R is a multiple of 12, 12k. And k takes the values 0, 1, 2, so on and so forth. But we are given the number of integral terms, that means the number of the terms where we get integers is 183. 183. So, the k should take values 0, 1, 2 up to 182. Because 0 is included, 183 terms will be 0, 1, 2, 3 up to 182. Therefore, k takes the values 0, 1, 2, 3 up to 182. 182. And what will be the maximum value? Maximum value will occur when k is equal to 182. So, the R max, the maximum value of R is 12k when k is 182. That is 12 into 182 is 2184. Now, look here, 0 less than or equal to R less than or equal to n. Maximum value of R that it can take is 2184. That means 0 less than or equal to 2184 less than or equal to n. What is the least value of n? N must be 2184. Now 0 less than or equal to r less than or equal to n, and r maximum value of r is 2184. That will give you 0 less than or equal to 2184 less than or equal to n. The least value of n must be 2184. Note that 3 divides 2184. That condition is satisfied. Agreed. So, the answer to this question is 2184, and that appears against option 2. That is the detailed discussion of the solution of this problem. Right. This question has appeared in the JEE Main exam held on 28th January 2025 in the second shift. Let the coefficients of 3 consecutive terms TR, rth term, r plus 1th term, r plus 2th term in the binomial expansion of a plus b to the power of 12 be in a geometric progression and p be the number of all possible values of r. P be the number of all possible values of r. Let q be the sum of all rational terms. Sum of all rational terms in the binomial expansion 4th root of 4 plus cube root of 11 to the power of whole to the power of 12. Then p plus q is equal to, we are given 4 options. So, this has 2 parts. First of all, we attack the first part and find out what is p. We have a plus b to the power of 12, and when you expand it in a binomial, the r plus 1th term is 12cr into a to the power of 12 minus r into b to the power of r. Agreed. We are given the coefficients of TR plus 1, TR plus 2 in the binomial expansion are given to be in a geometric progression. So that means the coefficient of TR plus 1 by the coefficient of TR is equal to common ratio. The coefficient of TR plus 2 by the coefficient of TR plus 1, the common ratio must be equal. What is the coefficient of TR plus 1? 12 CR by the coefficient of TR is 12 CR minus 1 is equal to 12 CR plus 1 by 12 CR. Now solve for R, and what are the possible values of R? And P is the number of all possible values of R. Therefore, you solve this one. 12 CR by 12 CR minus 1. NCR by NCR minus 1 is N minus R plus 1 by R. So, N is 12. So, also here 12 minus R plus 1 in brackets plus 1 by R plus 1. Now, simplify, cross multiply, simplify, and ultimately we get 12R minus R square plus 13 is equal to 12R minus R square. This will give you 13 is equal to 0, which is untenable. It's not possible. That means this equation 1 is not satisfied for any R belongs to n union 0, n union singleton 0. So that means the number of the terms, the P denotes the number of all possible values of R. There are no possible values of R. Therefore, P is equal to 0. Agreed. That's the first part of it. Move to the second part. Yeah. We have P is equal to 0. And we have the fourth root of 3 plus cubed root of 4 to the whole to the power of 12. Write it in the binomial. Write it in the binomial. Right. So this will be equal to, and the general term will be 12 CR into fourth root of 3 to the power of 12 minus R into cubed root of 4 to the power of R. That is equal to 12 CR 3 to the power of 12 minus R by 4. Fourth root means 1 by 3 to the power of 1 by 4. That will be written like this into 4 to the power of R by 3. Now this is 12 CR into 3 to the power of 12 by 4. 3 minus R by 4 into 4 to the power of R by 3. What is that we want to get? We want to get rational terms. That means the terms which are rational. And for that to obtain rational terms, we must have 3 must divide R and 4 must divide R, and the GCD of 3 and 4 is 12. It will imply 12 divides R. That means R is equal to a multiple of 12. So R is equal to 12K, where K takes the values 0 and 1. Why? R varies from 0 to 12, and K must take 0 and 1. If K takes 2, R will be 24, but R varies from 0 to 12 only. Therefore, 2 values only we take. So R is equal to 0 and R is equal to 12. So, going to the terms, rational terms, find out the rational terms. So, the rational terms are 12 CR 3 power 12 minus R by 4 into 4 to the power of R by 3 when R is 0. When R is 0, you substitute here, you will get 3 cube. And the same value from R is equal to 12. Substitute R is equal to 12 here, you will get 4 to the power of 4. So these are the rational terms, 3 cube and 4 to. What is Q? Q is the sum of all rational terms in the expansion. So that is 3 cube plus 4 cube, that is 27 plus 256, that is 283. So therefore, we want P plus Q. P plus Q is, P is 0 plus Q is 283, that is equal to 283. So the answer is 283. That appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the solution of this problem. Move to the next question. Right. This question has appeared in the JEE Main exam held on 24th January 2025 in the second shift. This is an interesting question. Suppose A and B are coefficients of 30th and 12th terms respectively in the binomial expansion of 1 plus x to the power of 2n minus 1. If 2a is equal to 5b, then n is equal to. We are given 4 options. Let's now discuss the solution of the problem in detail. We have 1 plus x to the power of 2n minus 1, right, the binomial expansion. Then the r plus 1th term is, general term is 2n minus 1 cr into x to the power of r. Agreed. Now we want the coefficients of 30th term. So the coefficient of r plus 1th term is 2n minus 1 cr. Right. A. What is A? The coefficient of 30th term. So the r is 29. R plus 1th term. R is 29. So 2n minus 1 C29. B is the coefficient of 12th term. So it will be 2n minus 1 C11. Agreed. We are given 2a is equal to 5b. 2 into a, 2n minus 1 C29 is equal to 5 into 2n minus 1 C11. That is 2 into, so NCR formula, n factorial by r factorial into n minus r factorial. So write down. Right, n is 2n minus 1. So now simplify. 2 into 2n minus 1 factorial by 29 factorial. This is 2n minus 30 factorial into is equal to 5 into 2n minus 1 factorial by 11 factorial into 2n minus 12 factorial. Right. Right. So we have cancelled 2n minus 1 factorial, 2n minus 1 factorial in the numerator. And 29 factorial will be 29 into 28 into so on and so forth up to 12 into 11 factorial. And that 11 factorial cancels with this. So you are left with 29 into 28 into 12. And that 11 factorial is cancelled. 29 minus 30 factorial into 29 and 2n minus 12 factorial. Out of these two, which is the bigger number? 2n minus 12 is bigger number. 2n minus 30 is a smaller number. So when you expand 2n minus 12, 2n minus 12, 2n minus 13, 2n minus 14, etc., etc., 2n minus 29 into 2n minus 30 factorial. So that tail, 2n minus 30 factorial, you can cancel. So that will be this one, 5 into 1 by this one, up to 2n minus 29. 2n minus 30 factorial is cancelled. Now here, note down, in the denominator, how many terms are there? How many? 29 up to 12, 17 plus 1, 18 terms. In this also, 18 factors are there in the denominator. Agree? Now this is written as 1 by 29 into 28 into 12 is equal to 1 by 29 minus 12, 29 minus 13, etc. into 29 minus 29, 2n minus 29 into 2 by 5. This 5 and 2 by 5. But you see, here you have 18 factors. And these are 18 factors. And now an additional term has come. That is the 19th factor. Right? So, to adjust the terms, what I do is multiply both sides in the denominator by 30. So, this will be 1 by 30 into 29 into 28 into up to 12 is equal to 1 by 29 minus 12 into 2n minus 12 to 2n minus 13 into 2n minus 29 into 30 into 2 by 5. Don't worry, 30 into 2 by 5 is 12 and you get 19 terms. That will be okay. So that is this one. 19. These are 19 terms. These are 19 terms. Now, 1 by 30 into 29 into 28, that's 12. And 1 by 2n minus 12, 2n minus 13, 2n minus 20, 12, 29 into 12. It is also ending with 12. Therefore, 2n minus 12 must be equal to 30. When 2n minus 12 is equal to 30, 2n is equal to 42, n is equal to 21. Right, here, when n is equal to 29 or 21, here 2n minus 29, and what will be the next term? The next term will be 2n minus 30. 2n minus 30 when n is 21 is 12. So the 12 is nothing but 2n minus 30 only. So it is adjusted. So no problem. No problem. Therefore, the answer n is 21. The answer to this question appearing against option 3. And that is the detailed discussion of the solution of this problem. So in this video, we have discussed 4 problems in the second part of the binomial theorem. So there is another third part is there. With that, the binomial theorem will be over. Agreed. I am sure that you have understood the solutions of these problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we are going to meet you once again for further discussion of the third part on binomial theorem. I wish you all the best. Thank you.